Welcome everyone. In this lecture I will discuss mathematical computations using GNU Octave. Well, in preparation of these slides, materials have been taken from different online sources in the shape of books, websites, research papers and presentations, etc. However, the author does not have any intention to take any benefit of these in her or his own name. This lecture is prepared and delivered only for educational purposes and is not intended to infringe upon the copyrighted material. Sources have been acknowledged. Where applicable, the views expressed are presenters alone and do not necessarily represent actual author or the institution. Following are the objectives of this lecture. The first one is to understand how mathematical computations are performed using Octave. Well, the focus over here will be on matrices and solving linear equations. And the second one is to get an overview of an application of matrices. Well, I will particularly focus on the application of image processing over here. The objective of this course is also to cover the course learning outcomes of this course. And the third learning outcome was that we have to implement the key concepts developed in the course using a mathematical simulation software. So this learning outcome will be covered through this lecture, and by the end of this lecture I will give you an interesting assignment as well, and in which you will develop the skills as well to make use of this software in an easy and efficient way. Here is the outline of today's lecture. First, I will cover the introduction to Octave. Then you will see how to create a matrix. Matrix creation is a very basic thing that you mostly perform. And secondly, we will see the various operations that are involved after you have created a matrix. And these operations include addition, multiplication, and division as well. But I will not cover division over here, because right now we have not even performed division in linear algebra. So I will just cover those aspects that we have already covered in our lectures. So the next thing will be finding out the transpose of a matrix. And by the end of this lecture you will see that how you will solve systems of linear equations. And systems of linear equations, in the first part of this course you have seen that you make use of Gauss-Jordan elimination. So that was a very long procedure to get the result, but in Octave you can achieve that using just a single command. So that will be also interesting to see. And by the end of this lecture I will discuss an application of matrices. GNU Octave, it's a high-level language that is used primarily for numerical computations. You can perform and solve a number of different problems related to mathematics over here. Like in today's lecture you will see that how you can solve matrices and systems of linear equations over here. And it can also be used for performing image processing. And you can also perform signal processing and a lot of things you can do using this software. So whenever one talks about Octave, then MATLAB is also discussed over there, because MATLAB is also a similar type of software that is used for performing all these tasks, but it's a heavy software, and it is a complex one as well, because it offers you a variety of functionalities to perform, and in whichever domain you would like to perform, whether it's signal processing or it's image processing, so you can do a lot of things with MATLAB, but it's due as it is a heavier one, and it will be difficult for you to download it because it's a heavy one. So I have decided to make use of Octave because it's a lighter version of that, and a lot of commands that we use in Octave are compatible with MATLAB as well. And the syntax for writing is also similar. So if you are comfortable with Octave, then you will also get familiar with MATLAB easily. And MATLAB is a software that you will work on it in different courses that you will study later on in this degree, like in signal processing, in digital signal processing, and in control systems. You will come across this software a lot of times. But if you have done some computations over Octave, then it will be easier for you to switch to MATLAB. So now there are two options for you to make use of Octave. One is the online version. Here is the link of the online link. Basically, online is easier and it's very light to perform. You can just, there is no need to download it. You just require internet access and you can enter your commands and get the results on the spot. Okay, so no download, nothing is required over here. But if you are not comfortable with the online version, then you can also download it, this software, through this link that I have given over here. And but I would suggest you to make use of online. But both platforms are same and you can make use any one of them. But I would prefer, and I would do all my computations of this lecture on the online one. So I will show it to you how it looks like. So as you can see, this is the online one. So just click here to reconnect. And now over here you can enter the commands. So it's, as you can see, that it's very clean platform, nothing complex, and you will just write the commands over here and press enter and you will see the results. What you will do is you will create a matrix. Now here I have shown a matrix which is a 3x3 matrix, and it has 3 rows and 3 columns. So if you have to write such a matrix, you will make use of this command, and what it will do is, let's say I want to give it a name of A, matrix A. A is equal to square brackets, then you will write the numbers that are in the first row, and after each element of the first row you can either give a space or you can put a comma over there. So it depends on you. So you can either place it comma or just give it a space. Then, like as you can see that we have in the first row we have 1 1 2, so 1 1 2, and now because we have to move to the next row, you have to place a semicolon over there. Then we have in the second row we have 3 5 8, just write 3 5 8 with commas or space between. Then for the third row, place the semicolon and write the numbers with commas or space and just close this bracket. So with this you will get a matrix of 3x3, just the way we have shown it over here. And one thing that is mentioned over here as well, that ending a command with a semicolon tells Octave not to print the result of the command. So this means, because as you can see that we have not placed a semicolon over there after the square bracket. So what it will do, it will just show the result to you, that when you have given this command, then how the result will look like. So but if you will place the semicolon over there, it will not show you the result, but it will do the function that you have asked it to perform. Show you different commands that are required to perform on Octave, and then I will move to the online version so that we can perform all these commands at the same time. So now let's discuss matrix addition. Now suppose that I have to add two matrices, matrix A and matrix B. Now as you can see over here, I have this matrix A, and in this we have 1 space 2. This means that in the first row of the matrix we have these two elements 1 and 2, and because there is a semicolon over there, it means that now we are moving to the second row, and in the second row we have again 1 and 2, and we have just closed this bracket. Then we have to mention the second matrix, that is matrix B. It is 1 1. It's again a 2 cross 2 matrix, and in the first row we have two elements 1 and 1, and in the second row we again have two elements 1 and 1. Now you want to add these two matrices and store that result into another matrix C. So I will mention that I want to create another matrix C, which should be equal to A plus B. A and B are two matrices, so I am basically adding these two matrices, and the result should be, as you know, that 1 will be added with the first element of A will be added with the first element of matrix B. The second element of the matrix A will be added with the second element of matrix B. So we obviously will get in the first row of C, I will get 2 and 3, just like the normal way you do addition. So the same result you will get. And one thing that I would like to clear over here is that always make sure that you are using the exact characters that you have specified. Like here I have used capital A and capital B, capital C. If I try to do A plus B, this A plus B will not give me the result. It will in fact give you an error. You have small b, it's a case sensitive language, so you have to specify capital A plus B. Only then it will work. Multiplication. Now in matrix multiplication, we are either multiplying a scalar with a matrix, or we are multiplying two matrices. So if we are multiplying a scalar, like here we are multiplying, we have already defined a matrix A, we are supposing this over here, and if we want to multiply it, we will make use of this star operator, 2 star A, and this will give you the result. And if you want to multiply two matrices, then you have to again make use of the star operator, but make sure that the rules still apply over here. If you are defining two matrices, the conditions that is required for multiplication should be fulfilled. That is, the columns of the first matrix should be equal to the rows of the second matrix. Okay, only then the multiplication will give you the result, otherwise it will give you an error. Is that if you want to take a transpose of a matrix, first of all, what is transpose of a matrix? If this matrix A is given to you, as you can see over here that we have this 1 2 in the first row and 1 2 in the second row, and I want to take the transpose of this matrix. Transpose just makes the rows of the matrix to the columns. It just shifts, like here we have this thing in row. If you take the transpose of this matrix, you will get this thing in the first column of the matrix. 1 2, I will get this 1 2 in the first column. In the second row I have this 1 2, I will get it in the second column. So this happens in transpose. Okay, now just I will give you an idea about all these things on the online platform. Here first I will create a matrix. A is equal to square bracket. I will create a 3 cross 3 matrix. So 1 1 1 in the first row, then coming to the second row 2 2 2, and in the third row I will have 3 3 3. Okay, now one thing I need to show it to you, that if you just enter this command, you will get something like this. Okay, so it is showing you the result. Now I will create B matrix. Just place the upper arrow, just enter the upper arrow, and you will get the previous command that you have entered already. So I will make just changes in it, because for B matrix as well, I am making it a 3 cross 3 matrix. So triple 1 in the first row, triple 1 in the second row, and 0 0 0 in the third row. Okay, now if I don't place a semicolon over there and just enter it, I will not get the result. I will not be able to see it. Okay, but this doesn't matter. Just you enter again B and you will get what you have entered. Okay, now I want to store this the addition of these two matrices in matrix C. So C is equal to A plus B. As you can see that I have entered small b. Okay, so this will not work. So make this capital A plus B, and as you can see, first element of matrix A will get added with the first element of B, and I will get 1 plus 1 2, 1 plus 1 2, 1 plus 1 2, and second row will get all threes, and in the third row of A, because I'm adding 0, so I will get 3. So this is how you can solve addition problems. Now the next thing that you learned was multiplication. So now I will create another matrix D and multiply 2 with matrix A. So as you can see, when you will multiply it with 2, each element of matrix A will get multiplied with 2. Okay, next thing I can do is I can basically multiply the two matrices. So again, let's say D is equal to A into B. So you can get the result because it is the two matrices are also following the multiplication rules as well. So you will get this result. Now coming to transpose, let's say because I have not this D matrix, let's take the transpose of this matrix. Transpose D. Okay, so now you can see that this 2 2 2 triple 2, which was in the first row, it should be now in the first column. 4 4 4 should be in the second, and 6 6 6 should be in the third column. So this is how you do transpose. Next thing is solving systems of linear equations. This thing was done earlier in this course when we solved linear equations using Gauss-Jordan elimination, and I hope you all remember that what was the procedure, and it was a long procedure. And let's see, here is the system of linear equations, and I want to solve it using Gauss-Jordan, and I want the final result to be in reduced echelon form. So let's see how you can do that in Octave. So in Octave, first of all, this was the system of linear equation that was given to us. Now I will write this in matrix form. As you can see that we have this x1 plus x2 plus 5x3. How you represent this in the form of matrix? You all know that this can be written as 1 1 5 3. Augmented matrix, we are talking about augmented matrix over here, because we have to write the thing that comes after equal to as well. 1 1 5 3. Next is we have no coefficient with x1, so 0. Next is 1, and the last one is 3, and after equal to we have minus 1. So likewise we will do this for the third equation, and this matrix we will get. Now to get the final result, that what it will look like, and with the help of which you can see what are the values of x1, x2 and x3, you can use this command of reduced echelon form, reduced row echelon form. And this, as you can see, that this is the final result, and this final result shows that this system of linear equation has no solution. For this you can refer to your textbook, because I have taken this question from your textbook. So this was the final result in the book as well. Okay, now I will discuss a very interesting application of matrices. I will talk about digital images, but I will not give too much details in this lecture, because it will be then out of context. I will just give you an overview of digital images and matrices, because this is a subject that is for this a whole course is basically designed to understand this image processing. In image processing, basically you learn how to process different images and how image processing is performed. So but over here I will just give you few details regarding that. First of all, we need to understand that what is a pixel. A pixel is the smallest unit of a digital image or a graphic that can be displayed and represented on a digital display device. If you notice that on a screen where a certain picture is appearing, and you try to zoom in that picture, just zoom in, zoom in, zoom in. In the end, what you will see that basically the picture comprises of small squares. The squares like this, as you can see on the left hand side. So when you zoom in, it is comprising of squares, and in those squares you basically see different colors. Though the picture does not appear in clarity, but you can see that the picture is basically formed from those squares. So the smallest unit, basically for an image we call this is the smallest unit, a small square. This is the unit of an image, pixel. So here I am talking about a 2D matrix, that an image is basically a 2D matrix. If you are talking about black and white pictures, it's just a 2D matrix. Basically, pixels are combined to form a complete image, video, text, or any visible thing on a computer display. Okay, so for you, I have created this slide where you can see that this is the arrow. Now, every time you see this sort of arrow on the screen, you think that it's like, as you can see, my arrow. It is looking very clear, and but if I try to zoom in this arrow, like over here in this picture, you can see the zoom in part of this. Not my arrow, it's a different arrow. So you can see that this arrow is made up from small squares. Okay, so these small squares together make this image of an arrow. But when you zoom out this picture, you get a much clearer version of what you are seeing. Another picture that I will show to you is of this star. Now, as you can see, I was talking about zooming in and zooming out. As you can see that on the left hand side, I have this star. Okay, so this star is appearing very clearly to me, but when I try to zoom in that, and as you can see on the right hand side, when I zoom in this thing, I will see that it gets blurred as well. And secondly, you will observe that the outline, if you see this outline, it is made of small squares. Basically, this whole star is made up from these small squares, and the smallest unit we call it as a pixel. We are going to create an image, and the image will be like this, as you can see it on your screens, that we have these two black lines on the sides, and we have this black square in the center. Now what I have done is that, as I was explaining to you earlier, that each image, basically when we are talking about a black and white image, I'm not talking about colored images, which we often say that it's a 3D matrix, colored images. This one, which is a black and white or a grayscale one, it's a 2D one. Okay, so here I want to create this sort of image, and this sort of image I want to color each pixel either black or white, because I know that to create this sort of image I have to give a color either black or white to each square. So to give it a how I will assign this a color. Basically 0 will represent a black and 1 will be represented with white. Basically 0 will represent black and 1 will represent white. These numbers actually set the intensity of the color. So as you can see that if you see this image is requires the matrix to be 7, 1 2 3 4 5 6 7 7. We have 7 columns, and 1 2 3 4 5, we have 5 rows. So we require 5 rows and 7 columns to define this type of image. And the first element of this matrix should be black. So as you can see that I have placed 0 over here. The second element should be white. So 1, basically 1 is representing white, and third, fourth, fifth, sixth, till 6 I will place 1, because I have to represent that part with white, and the ending element should be black, so I will represent it with 0. Now row by row you will decide that what number you will give it to that matrix. Now if you notice, this is our second row, the one that I am showing the cursor over. So this is the second row, and for the second row the first element is again black, so place it 0. The second element should be white, so place it 1 over there. Third element should be black, so place it 0. The other one should be 0, the other one will be 0, and the second last element will be white, so place it 1 over there and then 0. Likewise you will add numbers to the matrix, and when you will enter this matrix, then this image will not appear. Okay, so why? Because now I have to give it a certain command to show to display the image. So to display the image, I will make use of this command IamShow, and inside the round brackets you will place the matrix that you have made. So IamShow round brackets, inside that place the matrix B, and when you will enter you will get this result. And now what we can do with this image is that we can rotate this image. Let's say I want to rotate it to 90 degree, then 180 degree, then 360 degree. How I can rotate this image? I don't want to create another matrix for that. If I want these two lines to appear in horizontal rather than appearing vertically, I can take the transpose of it. If you remember what transpose does, so making use of that functionality, I can just rotate this image. I will take the transpose of this matrix and store this matrix in C, and then I will give it a command IamShow C. So when you will do that, you can see that now you have rotated this image. So in this way, if you now rotate this matrix C, you take the transpose of C, then you will get different direction. And now there are different commands to do it at to rotate the image at different angles, but we are not delving into that thing, because that is not the part of this course. This thing is to just make you understand that how important these matrices are. These are just not a set of numbers. We make use of them in the field of image processing. what I have done is that I'm just showing it to you that if you want to create a black and white image where you want the first two blocks to be black and this third one to be white, then in the second row we want white and then the other two ones black. I have created this image. Okay, now if I want, because I was saying that these numbers basically set the intensity of the image, so intensity of the colors basically. So if I want to transform this image a bit, what I can do is just make changes in these numbers. Let's say instead of 0, instead of creating just black, I can write 0.7, 0.8, and let's say 0.6, 0.5, and for the second row, let's just set it to 0.2, 0.3, just 0, then 0.5, 0.6, and 1. Okay, now enter it, you will get this. Now just show it. So here is the image. Now you can see that now we have a grayscale image, and here you can see the different colors of black and white. Black, basically we have shades of black over here. So in this way you can transform an image, and you can even rotate this image. Let's say I take transpose of it. Transpose. Now as you can see that you have rotated this image. Okay, so you can now I will suggest you, because it's a very interesting topic regarding image processing, I will suggest you to go to these last two links in the references. You will see these last two links. Just click on these links and you will see that very nicely they have explained these image processing concepts. Any one of you who is interested in getting more details regarding that, you can refer to these two references to get more details regarding this. Thank you. Thank you.